Hola, me llamo Andy. Mi presentación será en inglés. Espero que esté bien. Sorry, my Spanish is bad. Yeah, so as I say, my name's Andy. I'm from Trelleborg Navigation and Piloting, and I look after pilots in Europe, Middle East, Africa, and Canada. Today's presentation is going to be a case study of actual piloting in real life using a PPU system. And what this is, it's a project from 2021 from the UK and Scotland, the 4th pilots, where they used a Trelleborg PPU system to navigate and berth one of the world's largest barges, which you can see on the first slide there. So really, this story starts with an old gas platform in Morecambe Bay, which is in the middle of the Irish Sea, in between England, Scotland, and Ireland. It's about 20 kilometres offshore. So this gas platform topside had reached the end of its operational life, and plans were in place to decommission. Now, previously, historical decommissioning would have meant ripping it to shreds with blow torches and chopping and making a big mess. Lots of potential risk, damage. But Spirit Energy, the owners of the rig, wanted to decommission the system in a slightly different way, a more safe way, shall we say. So that just gives an overview of the location for anyone who wouldn't know where the Irish Sea is. So Spirit Energy engaged a company called All Seas, who I'm sure you may be aware of, to operate their super-sized vessel, the Pioneering Spirit, which at the time, and probably still, is the world's largest vessel. And the idea of that vessel is that it goes in alongside the rig, clamps round the legs, chops the legs, and then physically lifts the topside up. And then what happens is a barge, one of the world's largest barges, goes underneath, and they drop the topside onto the barge, which can then be moved ashore for decommissioning. As I say, the ship itself is one of the largest in the world. It's able to lift that topside. The topside itself is 7,000 tons, and that's an easy bit of work for that vessel. So you can see the vessel backing under the rig, ready to effectively cut the legs. So once it's disconnected from the legs, the Pioneering Spirit's got hold of the vessel there. The barge comes underneath, and the barge is called the Iron Lady. It's a 200-metre long barge. She just moves in between the two hulls, and then the topside is lowered down onto the barge and taken away. The Pioneering Spirit herself, she's a 400,000 GT vessel, and the build cost was only 2.6 billion. So the day rate on that vessel, I would imagine, is very, very expensive indeed. It's going through some lovely areas, through the Minch, which is between the Outer Hebrides on the top left there, and Scotland, and then finally through the Pentland Firth at the top of Scotland, where the full bore of the Atlantic pushes through into the North Sea, creating some horrendous whirlpools and currents. Really nasty bit of waterway to get through. And where the barge was being taken was down to the end of the Arrow, which is just off Edinburgh in Scotland. It's called the Firth of Forth. The word firth is a Scottish word which basically means fjord, so it's deep and steep-sided, ideal place to bring in vessels. I'm sure many of you may have been in there in your previous roles. But the decommissioning berth for this topside wasn't actually a berth. It was just a scrap piece of land that was out of the way of public sight for all of the decommissioning work that would go on. So bringing the barge into the actual landing had to be done very, very carefully, very slowly and accurately to prevent damage, first of all to the very expensive barge, but also to the topside and also the land itself. So this is where the story of the Trelleborg PPU came into effect. So on a normal day at Edinburgh port, effectively, the fourth pilots would use what we call as Cat 1 PPU units, which effectively plug into the vessel. As this project is a barge, it doesn't have a bridge, it doesn't have any electrics, it doesn't have any navigation equipment. And really the only place that you could even call a bridge is actually what you can see on the screen there is an old shipping container with a cutout so you can see what's going on. So a usual plug-and-play PPU system was not going to be of any use. They needed an independent system. They needed a system that was going to be super accurate as well. So the actual pilotage was going to have some very tight navigation, precision alongside work, and you can see the bridges that the project was going to be going under. There's some very tight air gaps there. And these bridges that you can see, these are kind of key to the British infrastructure. So you've got a main rail bridge and a main road bridge. So obviously ramming a barge with a topside into those was not going to be good. So the pilots were looking for an independent system, and they had a few kind of key requirements really that would work for the project. On the slide you can see the barge with the numerous tugs starting to move her around, but the pilots needed something with a long battery life. The longer the better. The project itself was going to take a minimum of 12 hours with a bit of extra time in case of any redundancy. It had to be portable. The pilots would be climbing up and down the barge ladders, which were fairly considerable ladders, and they wanted to take the PPU system up and down as they moved around, so it had to fit in the pocket. The PPU had to be very weatherproof, as you can see on that picture. Scotland is an interesting place if you've ever been there. So in the middle of summer you can have snow, wind and sunshine on a good day. So the system had to be fully watertight and able to withstand whatever Scotland could throw at it. Our PPU systems from Trelleborg are used on every vessel going through the Panama Canal, which, as you know, as seafarers, is fairly wet and humid conditions. So we've got full confidence that they're not going to get damaged by the rain. The pilots wanted to be sure that their system could show live air drafts, especially for the bridges. So the actual tide gauge readings from the port would feed into the PPU to give them an automatic air draft as they're going along during the pilotage. And then finally, the pilots wanted their own bathymetric charts to be loaded onto the system. So they didn't want to rely on as-issued ENCs, which could be 3-4 months out of date. So using the Trelleborg system, they're able to put their latest own bathymetric charts, which may have been done the day or two before. So the system that the Edinburgh pilots used was the CatMax system, which you can see on the screen there. It's a fully independent PPU system. So it's got its own AIS, heading, course, speed, position, and that's all to very high accuracy. So we're talking 1 centimetre position and 1 centimetre a second speed accuracy. So the CatMax tracks all of the 4 different satellite constellations, so GPS, obviously, Galileo, Chinese Beidou, and even the Russian GLONASS, which obviously, due to the situation in Ukraine at the moment, you have to keep a good eye on GLONASS availability. The Russians in certain areas, I think in Finland, they've been selectively availabilitying the accuracy level, so dialing down the accuracy. But what our system does, it looks for as many different constellations as possible to give you the most accurate fix, even if one of those constellations is possibly jammed or spoofed. I'm just going to talk really quickly about, for anybody that does have a PPU already, just something that kind of you need to be aware of. So PPUs that are just plug and play, that go into a vessel, so you plug into the pilot plug output. That, most people have seen that as a pilot, as a PPU as such. You've got to be very, very careful with quality of data coming out of the ship's GPS and AIS output. So these statistics are quite scary, but During the 2000s, there was a study of 500,000 vessels' AIS data, and 70% of the vessels had one type of error. So 47% displayed the incorrect length, 18% displayed incorrect beam, 6% showed 0 as length or beam, and 8% had a length or beam error of up to 5 meters. So I guess what I'm trying to say is, if you're just relying on a PPU that plugs into the vessel and nothing else, you have to be fully aware of where the errors could be. This is why at Trelleborg we always suggest that you add a second unit, which is an independent GNSS system. So you can see here, it's removing any potential error. As it's a GNSS receiver, it needs to be placed with a clear view of the sky. If it can't see the satellites, it's not going to get a good fix. One of the big errors that people who start using PPUs do is they will place it right next to a bridge, or they'll place it inside the bridge, and they'll wonder why it's not seeing a satellite. It's because it needs a clear view of the sky. Just in terms of accuracy levels as well, while we're here, if you're just relying on a ship's pilot plug output, you could be talking about a 5 meter plus minus accuracy. Once you start to bring a PPU into the system, whether it's Navicom, Dynamics, Trelleborg, or AD Navigation, you start to bring the accuracy level down to about 60 centimeters. Once you get to a top-end system, you're talking 1 centimeter accuracy. Obviously, if you're berthing expensive, delicate ships, the more accurate your PPU system, the better. So we can see on this slide, I'm going to move a bit quicker because I'm probably going to run out of time. I want to get to the end of this. Yeah, some of the pinch points were obviously the air gap on the bridge. Not necessarily with the top side of the rig, but the flare stack. The clearance on the flare stack was very, very tight. But they managed to get around everything without touching anything, which was good. This is an example of what the pilot on board would see. So literally they're navigating the whole project from an iPad. And one of the reasons that we, as a company, choose iPads, and we often get the question, do you work with Windows or Android? The answer is no, we work purely with Apple. A couple of reasons. Apple switches on almost immediately, so when you get on board the vessel, you want to get to work straight away. You don't want to wait for any booting up or anything like that. And also, we feel that Apple is a more secure digital environment, especially in today's world where people can spoof and jam and hack things. I'm just going to finish off with this to say that basically the project went really well, no problems. I hope you've enjoyed some of the images. I probably could have talked for an extra 45 minutes, but I just wanted to give you a flavour of what was happening. What you're seeing here is a 400-metre vessel coming out of Southampton, one of their most difficult berths, obviously backing off the berth. And if you want to talk about PPUs, come and see myself or Craig. We're here all day. Thank you.